Okay, we'll get started. In this video we're going to be going through 1b, which is proportionality. So the first thing in proportionality is to realize that equations that only have multiplication, division, and exponents are proportional relationships. Proportional relationships, or proportional equations is another way of saying that. So the reason we care about these is proportional relationships show up a lot in science. An example of that would be E is equal to mc squared. That's a proportional relationship. And the thing with proportional relationships, the reason they're kind of nice to work with is it's fairly easy to see if something happens to one of the variables, what's going to happen to one of the other variables. So for example, let's say the mass m increased in this equation, E is equal to mc squared. Let's say m went up. But if we look at this equation, if this side goes up, it's not too difficult to see, okay, well, this side's going to go up too. Right? That's because it's a proportional relationship. If one thing happens, there has to be something on the other side that balances that out. So again, kind of same thing in this case if m went down. So if m went down, E would have to go down. So it's that we care a lot about in science, because these variables actually represent physical things that are happening. So if you change one thing, how does that change something else, basically? So that's why we care about these type of equations, proportional relationships or proportional equations. So let's see an example. So example A, we have down here, A is originally $2. The variable A is related to B, C, and D by the equation below. And it's saying how will A change? So A is originally $2. How will it change if B is doubled? So if you had 2B. If C is cut in half, half of C, and then D is multiplied by 3/5. So if all those things happen, it's basically saying what's happening to A. So because there are multiple things happening, right, B's going up, C's going down, and D's going down, it's hard to tell exactly what's going to be the total effect of that. So that's why we kind of do this math out, to see if all of this stuff happens, if all of these variables change, what's going to happen to A ultimately. That's what we care about. So first thing we need to do is find the multiplier for A, so how much A will be multiplied by, how much its original value will be multiplied by if all this happens. So what we're going to do is we're going to take the equation kind of as is, and instead of the variables, we're going to plug in the numbers for representing what factor they change by. So we're going to do it right here. So multiplier B, instead of the letter B, we're just going to write a 2 because it doubles. C, it's a half, but we have to make sure to keep the exponent because that's important, so we're going to keep the squared, and then that's going to be over what? That's going to be over 3/5. 3/5. So again, this is the multiplier. So again, the original value of A is going to be multiplied by this value. But to figure out what it is, we got to simplify a little bit. So 2 times a half squared is going to be a 1/4. That's over 3/5 still. At this point, you could do two different things. The first thing is you could plug it into a calculator and just get a decimal, or you could do a little more simplifying to get it out as a fraction. Either one's okay. I'm going to save a little bit of time here by just punching it into the calculator and then converting it back to a fraction with one of the functions. So again, you could do it as a decimal too. So if we do this out, if we simplify this number, it's going to come out to 5/6. So 5/6 down here. So that's the multiplier. Again, if you had it as a decimal, that's okay too. That's fine. So the new value of A is going to be the old value of A, what it was originally, times this multiplier. So in this case, what is that going to be? That's going to be the old value, which was $2. Right, it says it up here. $2 times the multiplier, 5/6, is going to be $1.67. So again, this looks kind of strange, but really what it's saying is if this equation relates the variables, if these things change, if B, C, and D change, how is A going to be affected? And it's this kind of format you need to use to figure out mathematically by what factor it's going to go up by, and then that lets you figure out the new number. So in this case, you had $2 originally, and some stuff changed with some of the other variables, and now you have less money. You only have $1.67. So with this, it's probably good to see another example because it is a little bit of a strange idea. So we're going to do one that's kind of similar to this. Here we go. So for this one, again, like normal, see if you can do it out first. Again, it's pretty similar to the other one. There are just a couple changes. It's the same format though. So see if you could do that first. Okay, so I'll go through this. So again, very similar to the last one. That's on purpose so you can kind of see how these would look. So the first thing, it's really like the same problem. It's A is originally $2. The only thing that's different is the equation. So all the variables change by the same amount. A is originally $2. You just need to see what's the new multiplier, what's the new value of A. So to figure out the multiplier, we're just going to plug in the factors for each one of these variables, making sure to keep any exponents. So B is doubled, D is cut in half, or yes, C is cut in half, but C is now in the denominator and it's squared, and D is multiplied by 3/5. So we're going to simplify this a little bit. 2 times 3/5 over a fourth. And again, a couple different ways you can do this. You could either do out the math to simplify it, or you could plug it into a calculator. Both are okay here, so whatever you would like. Either way, that comes out to 24/5, or if you just punch it in, it's 4.8. Either is okay. So the new A is going to be the old A times the multiplier. So the new value of A is going to be the old value, that was $2, times the multiplier, which I will say is 24/5. 4.8 would be equivalent. And that's going to be 9.60. So that's the idea. Again, it's a very similar thing that's happening. A is originally some value, some stuff, it's related to all of these other variables, some stuff changes, what happens to A? In this case, A was originally $2 and then a bunch of stuff happened and then it's now 960. So that's the idea with proportionality. Make sure you have the notes, make sure you have this problem down, and that's it for now.